Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in our this lecture. In last lecture we complete our second unit. Now in this lecture we will start at our unit number 4. This unit is divided into two parts. Part 1 is synthesis part and second part is theory type. So first of all we start with synthesis of some applicable drugs. Some of drugs we list out here in this unit. We synthesize number 1 mebendazole. Second compound is tolbutamide. Number 3 is isoniazid. Number 4 is metronidazole. Number 5 is diphenhydramine. Number 6 is amphetamine. Number 7 is chlorambucil. Number 8 is chlorpromazine. Number 9 is ibuprofen. And last, number 10 is sulfomonoxazole. It is also known as sulfioxazole. So in this lecture or in this unit we synthesize these 10 type of different classes of drugs. So first of all we start with our first compound mebendazole. And also we discuss their medicinal application or their application which are useful in medical treatment. So we start first drugs synthesis of mebendazole. Mebendazole. Chemically, mebendazole is known as methyl 5-benzoyl imidazole 2-carbamate. And we see the structure. First of all, we see the structure of mebendazole. It is the structure of mebendazole, and chemically it is 5 methyl 5 benzoyl imidazole 2 carbamate. This is the structure and chemical name. Now we see the synthesis. First of all, we see the synthesis. Its chemical name is mebendazole, is known as methyl 5-benzoyl imidazole. Methyl 5-benzyl imidazole 2 carbamate. So, first of all, we use starting material for mebendazole is, it is known as fluorobenzene. Fluorobenzene, and second compound is COCl benzene ring, and its name is benzyl chloride. Benzyl chloride. Fluorobenzene and benzoyl chloride is condensed in presence of anhydrous AlCl3. When these two chemicals are condensed with help of anhydrous AlCl3, so HCl is removed and we get subjected our compound F benzene ring, C benzene ring O. Here from Cl and one hydrogen from this compound removed and we get our subjected compound. Now this compound is undergone, first of all we see nitration, unit process nitration, and then we see ammonolysis. So we get we get 4,3 amino nitro 4,3 amino nitro benzophenone. So with the help of fluorobenzene and benzoyl chloride, first of all we see preparation. Fluorobenzene and benzoyl chloride is condensed in presence of anhydrous aluminum trichloride AlCl3. We get subjected product, intermediate step, and the product obtained is subjected to first of all nitration and then ammonolysis gives 4,3 amino nitrobenzophenone. 4,3 amino nitrobenzophenone. Now this 4,3 amino nitrobenzophenone is hydrogenated over palladium or carbon, and then acetylation of this product is give mebendazole. So we see above this synthesis. First of all, these 3,4-amino nitrobenzophenone is treated with hydrogenated palladium or carbon. Hydrogenated palladium or carbon, and then we treated acetylation. So we get our product mebendazole. It is methyl 5-benzoyl imidazole 2-carbamate. So, first of all, fluorobenzene and benzyl chloride is condensed in presence of anhydrous AlCl3, and the product obtained is subjected to nitration, and ammonolysis gives 4,3-amino nitrobenzophenone, and this amino nitrobenzophenone is hydrogenated over palladium or carbon and then acetylated to obtain mebendazole. Now we see medicinal application of mebendazole. Mebendazole is used in mebendazole is used in Anthelminetics drugs. We discussed these drugs in our first unit. It is active against whipworm infestations. Here we complete our first compound, mebendazole. Now we see second compound, tolbutamide. Second one is tolbutamide. And chemically it is known as an butyl aminocarbonyl for methylbenzene. Sulfonamide for methylbenzene sulfonamide, or it is also known as, chemically it is also known as 1-butyl 3 paratoluene sulfonyl urea. 1-butyl 3-paratoluene sulfonyl urea. This is tolbutamide and it is anti-diabetic drug. Tolbutamide, anti-diabetic drug. So, first of all, we see the synthesis, preparation or synthesis of tolbutamide. Tolbutamide. We stated here, chemically tolbutamide is N-butyl amino carbonyl 4-methyl benzyl sulfonamide or 1-butyl 3-paratoluene sulfonyl urea. And tolbutamide is synthesized by paratoluene sulfonamide. Paratoluene sulfonamide. This is intermediate step, and in sulfa drugs we get it. It is known as paratoluene sulfonamide and it is treated with NH2CONH2. It is known as urea. Urea and paratoluene sulfonamide. When paratoluene sulfonamide and urea is treated in this reaction, both compound paratoluene sulfonamide and urea are heated together and we get paratoluene sulfonyl urea. Paratoluene sulfonyl urea. Here NH2 and one hydrogen from here. So when heating both compound together, ammonia is removed and we get SO2 NHCONH2. It is known as paratoluene sulfonyl urea. Paratoluene sulfonyl urea. Now, this paratoluene sulfonyl urea is treated with methanol in presence of sulfuric acid. Methanol CH3OH in presence of H2SO4. So CONH2 is converted into CONH2. This functional group is converted into ester group. Ester group. So we get our intermediate ester step CH3 benzene ring SO2 NH and CONH2 is converted into COOCH3. COOCH3. Now, this product is treated with butylamine. 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 CH2, 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 CH3. This is N-butylamine. When we heated our ester intermediate compound with butylamine NH2, CH2, 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 CH3, we get our final product tolubutamine CH3 benzene ring SO2 NHCO and then NH CH2, 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 CH3. This is tolubutamide. Tolubutamide. And its medicinal application, it is anti-diabetic drug. It is anti-diabetic drug. It is used as oral hypoglycemic agent. Oral hypoglycemic agent. So, this is our second compound, tolubutamide. We see the reactions here. Para-toluene sulfonamide and urea. Para-toluene sulfonamide and urea are heated together and the product is treated with methanol in presence of sulfuric acid and then with N-butylamine we get our product tolubutamide. Here our second compound is complete now. Now we see our third compound. In this lecture we synthesize three compounds. So number 3 is isoniazid. Number 3 is isoniazid. It is also known as INAH, isoniazid, or it is known as isonicotinic acid hydrazide. Isoniazid is also known as INAH and also isonicotinic acid hydrazide. So, first of all, we see our isoniazid synthesis and then we see medicinal application of isoniazid. So, in synthesis, isoniazid is prepared by 4-methylpyridine. 4-methylpyridine. We have structure of pyridine. this is pyridine, and this is 4-methylpyridine. Pyridine is 6 member 1 nitro as heteroatom and simple compound. So this is 4-methylpyridine. This 4-methylpyridine is oxidized when oxidation unit process takes place. So CH3 is converted into COOH with removal of hydrogen. We get in fourth position CH3 is converted into COOH, and this is isonicotinic acid. Isonicotinic acid. With the help of 4-methylpyridine, when this is oxidized, we get isonicotinic acid. Now, this isonicotinic acid is undergone by esterification. Esterification with the help of ethanol in hydrochloric acid, ethanolic HCl. So, esterification takes place. So, we get in presence of ethanol and HCl, our isonicotinic acid is here. This COOH group is converted into ethyl acetate, COOC25, and it is known as ester or ethyl ester nicotinate. Isonicotinate, sorry. Ethyl ester. Now, this is treated with hydrazine. This compound, this ester is treated with hydrazine. Hydrazine, NH2NH2. It is known as hydrazine. And removal of ethanol, C2H5OH. Removal of ethanol. We get CONH NH2, and this is isoniazid. Isoniazid or isonicotinic acid hydrazine. Isonicotinic acid hydrazine. So we get isoniazid from 4-methylpyridine. So 4-methylpyridine is oxidized to isonicotinic acid, and it is esterified and then treated with hydrazine to get isoniazid. It is used as anti-tubercular drugs. Anti-tubercular drugs. Anti-TB drugs. Isoniazid is anti-TB drugs, and the bacteria for TB is known as Mycobacterium tubercular. Mycobacterium tubercular. So, isoniazid is used in anti-tubercular drugs. Here we complete three syntheses. First of all, we synthesize mebendazole, then tolbutamide, and last one is isoniazid. Remaining compound we will see in our next lecture. Okay, thank you.